All right, gentlemen, today we're looking at 8.5 volume of a cone. And you may have noticed on the last day's handout that there was a question at the end that looks very familiar. Here it is right here, number 2. And this question, you were not able to answer because we did not cover volume. So that was your segue into volume. But some of you may have gone ahead and been extra vigilant and gone ahead to look at the formula for volume of a cone and got it, and that's great. Or you may have attempted it, and that's exactly what I wanted you to do, to be inquisitive and look deeper. Okay, so what I want you to look at right now is review. Isolate for the variable indicated. So we want to isolate this formula for W. How do I get the W by itself? The first thing I like to do is I really don't like the 3 here, so I could multiply both sides by 3. Or another way of doing that, again, it's actually the same thing. Think about it like this: V equal 1 in the numerator. All this is a numerator. It's right because technically the LWH, length, width, and height, is over 1. And you have 1/3 times that. So what we're going to do is we're going to rewrite this as LWH over 3. It's the exact same thing, just written differently. And then we're going to cross multiply this and this. But under the V, we have technically a 1 as well, right? V over 1. So if I cross multiply, I get 3V equal LWH. And if we multiplied originally, if we decided instead to have multiplied each side by 3, we would get these 3 crossing out and be left with LWH. And on this side, if you multiply by 3, you get 3V, which is exactly what we have here. Now, keeping that in mind, we're actually not done. We need to still, sorry, I just meant to erase that. We still need to complete isolating the variable W. So let's divide both sides by L and H. And we have divide by LH. So W is going to be equal to 3V divided by LH. I know it looks like a 1H. To be a little more clear, what we could do is make that italicized and just do something like that for L, okay? But for the sake of this lesson, let's just do that, okay? That's what W equals. And try to make that proper. Okay, let's look at this one here. Volume equal 1/3 pi r squared h. Well, now I just showed you an example of what to do when you have a denominator of 3. Let's see if you could do this one on your own, okay? So I'll leave that to you. And the learning goal here is whether or not you can apply this formula and use volume of a cone, 1/3 pi r squared h. It's kind of like the what I showed you last day with the triangular pyramid. I gave you a drawing that looks something like this, and I basically said if you had a pyramid in there, if you had a pyramid at the bottom, and we did this, something like that. That pyramid is 1/3 the volume. And that's exactly what we have here. So here what we're going to do is we're going to imagine, and I drew that for you already, imagine that this is a cylindrical container, and this cone is cut out of that cylindrical container. So technically, if it were a cylinder with the exact same dimensions, if it were 8 centimeters high, and if the radius right here were 3 centimeters, then the volume would be area of base times height. Well, the area of a base of a circle is pi r squared. So pi r squared is area of the circle at the bottom, right, times the height, which is 8. But in this case, because it's a cone, it's 1/3 of that volume. So it's 1/3 pi r squared h. And that's how we get our formula. Okay? So now that you're armed with that intelligence, let's go ahead and calculate the volume of the cone to the nearest cubic centimeter. We're going to say volume equal, and always you want to start off with your formula, pi r squared h, and then plug in what you know. 1/3 pi times the radius is 3, so we can say 3 squared, but you know 3 squared is 9. So why not just say pi times 9 times 8? I don't need to put brackets around the 9 here, you'll notice, because pi and then 9 is very clearly differentiated. So, but 9 and the 8, obviously I need to do that. And then I'm just going to use my calculator and let it do the work for me. 1/3 pi times 9 times 8. So I have 1/3 times pi times 72, because I know 9 times 8 is 72. Okay, and we get 12.5663, so I'll just say 12.57, and we'll stop it there. Actually, I apologize. It says to the nearest cubic centimeter. So we'll say 13, about 13 centimeters. So the volume is approximately 13 centimeters cubed. Actually, I should put that in red. Very important that you put cubed. Okay. Cubic centimeters because, and the reason why there's a 3 there is because there are 3 dimensions, right? There's area, which is 2-dimensional, and height, which is your 3rd dimension. All right, so this question should look familiar. A funnel in the shape of a cone, and we'll just kind of sketch this out. So here's a funnel in the shape of a cone, has a radius of 5 centimeters, so we know that's 5 centimeters, and a height of 20 centimeters. So from here to here is 20 centimeters. If it's full and drains at a rate of 25 mils per second, how long will it take to empty? You'll recall from last day I let you know that 1 cubic centimeter is equal to 1 milliliter. Now, armed with our formula, let's put that aside. Armed with our formula, volume equal 1/3 pi r squared h. R looks like a V, sorry. R squared h. Let's sub in what we know. The volume equal 1/3, times pi, times the radius, which is 5 squared, we know is 25, and times the height is 20. Okay, so we're going to plug that in our equation, into our calculator. 1/3 pi, and I believe, sorry, it was 25 times 20 times 25 times 20 is 523.6. So 523.6 approximately, and that's cubic centimeters, which technically is equal to, in terms of capacity here, is equal to 523.6 milliliters. Well, if that drains at 25 per second, right? Let me take this here. So we know that equals, oops, I think I took out the decimal. That's okay. Let's move it over here. No big deal. We'll go back here and erase that little decimal and give this guy back his decimal. There we go. So that's about 523.6 milliliters. And so therefore, if I divide that by 3, by 25, because it drains at 25 milliliters per second, we will get our answer. So this, basically I'm going to do this, and I'm going to do the whole thing divided by 25. And we'll get 20.94. So equal approximately 21 seconds. Because it's draining at 25 milliliters per second, and my answer came out to 20.94, that's about 21 seconds to drain. Okay? Or to empty. Let's say empty. That makes more sense. Okay, and that's it. All right, so you have this question here to do on your own, and we'll see you in class.